Hello algebra, and welcome to our next polynomial topic, which is multiplying polynomials. And this may be the first time you, in a little while, seen something brand new. So multiplying polynomials, we're going to use a different system. As you can see by the learning target, it says I can multiply two polynomials of any length using a grid. And you might be thinking, what the heck do we need a grid for? Well, I'm going to start off with not two polynomials, but a monomial, something like 3x times another polynomial. We'll just do maybe 4x squared minus 5. So this you wouldn't really use necessarily a grid for. You can just distribute. Because of this one term out here, we can multiply. So we get 12 x to the third. Notice we're using the rules that we learned the first day about multiplying monomials. And then 3x times negative 5 would be negative 15x. And that's it. That's super simple. It's when we get into this one being also a polynomial that it gets a little bit different. And this is what they will look like. So this is a very simple one. We have x plus 1 times x plus 2. And those parentheses are very necessary because if you don't have the parentheses, it only looks like you're multiplying certain parts. So the idea is every term over here has to multiply with every term over here. So in other words, x has to multiply by x has to multiply by 2. 1 has to multiply by x, and 1 has to multiply by 2. And I actually call that method, if you just do it that way, the claw method. It looks like a lobster claw. But we're not going to do that method because it changes every time you have a different polynomial size. So instead, we just look at it and say, okay, this is 2 terms, this is 2 terms. So I need a 2 by 2 grid. And then you write the polynomials on the top and left. So x plus 1, you can put it on the top or the side, it doesn't matter. And you don't need the plus, you're just putting each term in one of the columns. So x goes in a column, 1 goes in a column. If it was x minus 1, you would put a minus here, but it is not. So x plus 2, or x and 2, go on the left side. And then it's just like Battleship. Where they meet, you multiply those two things. So where x and x meet, they become x squared because you add these little invisible ones. Where x and 1 meet, you can either write 1x or just x. X and 2, where they meet, it is 2x. And 2 times 1 in the bottom right corner is just 2. Alright, but that's not the end of the problem. You cannot leave your problem like that. What we have to do is combine all the boxes that contain like terms. So in this case, that would be the x terms. They both end in x. This one's a 1x, this one's a 2x. So I can combine these. And because we always combine, it's not always, but often they're the top right and the bottom left. I call it the peanut. So we combine the peanut. And we get x squared. So notice that didn't combine with anything. And then you have to add 2x and 1x to get 3x. And then the 2 doesn't combine with anything. It's a positive 2. And there's your answer. You almost always get something longer. It was a 2 by 2, and we end up with a 3-term polynomial. Alright, we're going to try a couple more examples so we get the hang of it here. This first one, notice it's a 3 by 2 grid, and that is because we have 3 terms in this polynomial and 2 in this one. So you don't really have a choice once you build your grid that way. You have to put the 3-term polynomials where there's 3 columns. So notice on the 8, it's a negative 8, so I want to make sure that is included with that one. You're basically writing this whole thing out. You just don't have to write the pluses. And then n in negative 3, or n minus 3. And you just start multiplying. Remember the little invisible ones? That's usually what people make a mistake on. They forget to add that little invisible one. So this is n to the third. This is 2n squared. And this is negative 8n. Down here we have negative 3n squared. And then negative 6n and finally a positive 24. So again, we mark off where they can combine. I'm looking for matching variable terms. N squared, they will combine. Choose a different color here. And then N and N, they combine. There's 2 peanuts. Alright, so then we get N cubed. And then I'm combining negative 3 and 2, I get negative N squared. I combine negative 6 and negative 8, I get negative 14N, and then a positive 24. So it turned into a 4-term polynomial answer. And you can't go any further than that. That's the end. This is not an equation. We're not trying to find what n is. You're just trying to multiply 2 polynomials and get a new expression. Alright, this one really isn't much different. It just has an x squared in it to begin with. But you can see it's not going to change much of anything. We get x, the little one there, so x to the third. We get negative 2x. We get 5x squared here, and then a negative 10. Now the interesting thing is there's no peanut for this one, because they're all unique. X to the third, x squared, constant. So you just basically write everything. But you should write them in descending order of exponents. And that's the standard way to write an expression. You start with your highest exponent first, and then work your way down. If there's more than one letter, it's kind of hard to follow a certain pattern, but when they're all the same letter, you go from highest exponent to lowest exponent. Next we have one that has no numbers in it at all, and there's no grid here. And normally they're not going to give you a grid, they just say multiply these, and not every teacher teaches it with the grids. In fact, we didn't for a while because we didn't have to multiply anything more than a 2 by 2. So we had a different method called FOIL, and maybe if you have older siblings who are like, oh, I don't want to do this, you just FOIL it. We'll talk about that in class. If you remember, you can ask me about it, what FOIL is, and that's what we used to teach. But now that we have tougher problems, we had to have a new method that worked for everything. So here we go, 2 by 2, but just letters. XY, X, negative Y. Remember, every single one of these has an invisible little 1 on it. So we get x squared. When you multiply x and y, it is just xy. And then negative xy. And I sometimes get people confused because they think I just arbitrarily moved the negative to a different variable, and that's not allowed. But it actually is. A negative y times an x, they're just numbers. So if you had like negative 10 times 5, it's still negative 50. It's just the whole thing is negative. So I can move the negative out front. You certainly don't want to write this, because that does not look like x times negative y. That looks like x minus y. And I see that once in a while. It's very confusing for them. And then negative y squared. There are 2 terms here that are alike. These 2 both end in xy. So we can add them. And remember, this is a 1xy and a negative 1xy. We'll do that in a different color because it was not there originally. It looks like I'm crossing it off. So what happens when you add a 1 and a negative 1? You get nothing. So you don't even write it. So those things cancel each other out. And that happens quite often. So you get x squared minus y squared. Alright, the last problem we're going to do together is going to be what we call shaded region questions. And shaded region questions pop up in lots of areas of math. And the polynomial famous one I call the square donut. It asks you to do 3 things. Sometimes they ask you to find perimeter too, but we're going to skip that because that's an adding thing. We did that last time. So in the end, to find the area of the shaded region, and by shaded region they mean the area of just the green part here. So if you want to know just the area of that green part, we're going to have to do a couple things. We're going to have to figure out the area of the entire thing. So if I were to move the donut hole out of there, I would need to know the area of that green square right there. Then I need to know the area of this guy, and then subtract it away from the area of the green so that it's kind of like stamping out the hole. So we have to do a little subtraction at the end. Alright, so the first task is express the area of the larger rectangle as a trinomial. They just kind of tell you it's going to be a trinomial at the end. So we have 3x plus 10 times 2x minus 3. Well, so this is a polynomial times a polynomial. So we're going to need a 2 by 2 grid. We're going to have 3x and 10 on the top, 2x negative 3 on the bottom, or on the left, excuse me. And those can be switched. You could have 3x and 10 on the left and 2x negative 3 on the top too. So we've got 6x squared, 20x, negative 9x, and negative 30. Remember too, this just popped up totally off track, but when you're taking notes and you care about understanding it by the end, don't just write. You can always pause it and just try to guess what I'm going to do, or just do the work before I do it, and then sit back and watch it be the same as yours and be really excited. So that's one tactic you can do while taking notes. Don't just kind of lay there and write what I write and in the end hope that it all sunk in. Be active during the notes. Try it yourself. It's actually more fun. I know that fun might be the wrong word, but it's more interesting than to just copy. Alright, so let's write our terms combined. We get 6x squared, 20 and a negative 9, so it's just 20 minus 9 is 11 minus 30. And I'm going to leave it right there because that's all I can do for now. Now I got to find the area of that little white rectangle on the inside, and that would be x plus 4 times x plus 3. We never even said in the beginning why am I multiplying those two things? Well, area of a rectangle is length times width. So that's why I'm multiplying those two. Probably should have said that first. Alright, we're going to need another 2 by 2 grid. This one will be a little easier though. We get x squared. Remember the little ones. That was always hidden. Alright, and then 4x, 3x, and 12. So when I combine that, I get x squared plus 7x plus 12. So I have my two areas, and while they're not very satisfying examples of an area, that is what it is. They're polynomials. We're going to have to find the area of the shaded region by taking the big one, this one here. Oh, let me get a different color. I had to go with purple. So you take the area of the large one minus the area of the small one. So you got to make sure you have the order correct. So it's 6x squared plus 11x minus 30 minus x squared plus 7x plus 12. So if you remember from last video or last class, it's imagining a negative 1 here and distributing it. And as I write, I'm going to write it underneath the first one. So that would be negative 1x squared. That would be negative 7x. And negative 12. They just all turn negative. And then I combine. Negative 30 and negative 12 make negative 42. 11 and negative 7 makes 4. A positive 4. And then 6 is basically 6 minus 1 is 5x squared. And as soon as we know what x is, we would be able to figure out what the area of the shaded region is. But for now, we have to leave it like that. Alright, I am leaving you with one final task, and I think it's the slide before. Yep. It is a 3-term polynomial times a 3-term polynomial. So you have to figure out what kind of grid am I going to have, and then start doing some multiplying. There's going to be a little bit more multiplying than normal, and then combine things you can combine. And there might be more than 2 things you can combine together in this one. Good luck. Be checking for that when you come in. Have a wonderful night.